In this video, I am going to show you how you can integrate LlamaIndex with AWS RDS. LlamaIndex is a framework to create generative AI applications by using large language models, whereas AWS RDS is a managed database service from AWS Cloud, and you can have databases like MySQL, Postgres, Oracle, SQL Server within this RDS. For this demo, we'll be using Postgres database. I already have created my AWS RDS database in Postgres, which is quite simple. All you need to do is to log into your AWS console and then go to RDS service and create your Postgres database. For Postgres client, I am using pgadmin, and you can download pgadmin for free from internet. And once you have it, you can simply go ahead and create whatever tables you have. I have created two sample tables here, as you can see. So first table is this companies table. I have just put in some sample data like 4 rows. Company name is AWS, Azure, GCP and Alibaba, and I have given it a primary key from 1 to 4. Similarly, I have defined another table called as contacts, in which I have just populated 5 rows with different names, and then I have put in company ID as foreign key here. So this is one to many primary to foreign key relationship between companies and contacts table. For instance, here we can see that John Doe and Jane Doe, they have company ID 1, which means that they work in company ID 1 here in AWS, and similarly for the other contacts they have different company IDs. So these are two simple tables which I have created in my Postgres database just to play around with this application which I'm going to build with you by integrating LlamaIndex with AWS RDS. Okay, so that's out of the way. Let's go back to my Ubuntu system. And the Ubuntu system which I'm using is Ubuntu 22.04, and I am using a simple Linux instance. You know GPU required, you can do the same. Another thing, make sure that you have OpenAI API key set if you are using GPT-4 or GPT 3.5. If you want to use any other model, then there are other steps, but I'm using OpenAI's GPT-4, so I have already set my OpenAI key. That's done. Now the first step you need to do in order to use this is to install the libpq library, which will enable you to access Postgres from your Linux instance, and I already have done it. If you haven't done it, run this command and it will install this libpq and Postgres configuration on your system. And don't worry about these commands, I'll put them in my blog and I'll drop the link to it so that you can also run these commands. So Postgres is done on this Ubuntu. Second step we need to do is to make sure to install these prerequisites libraries such as LlamaIndex, SQL Alchemy and scikop-g2. LlamaIndex for natural language querying by using LlamaIndex framework, of course. SQL Alchemy to connect to the Postgres database, and scikop-g2, it enables us to use DB API, which is required by SQL Alchemy. I already have installed it, so I'm not going to rerun them. And now let me fire up my Python interpreter. So there you go. So this is the Python I'm using. Just to make things easier, let me run this lambda command to make sure that I'll be able to clear my screen, so which will make things easier. That is done, and now let's begin doing the magic with LlamaIndex. So first thing, let's import some of the modules which we have already installed, such as Alchemy, LlamaIndex, and then all the vector databases and SQL table schema. Vector store index enables us to store embeddings, because when we give the text, large language models, they need it in embedding or vector format. Okay, so that is done. Now let's specify our endpoint to Postgres database. If you have used Postgres database in RDS, you know that it consists of something like this. It has, so first we are specifying driver, then we are specifying database name, which is username Postgres, password 1234. Of course, this is not a security best practice, but this is just a test. And then our endpoint for the RDS, and then port is default, and the database which I already have created is called as testdb. So that is set now. Now let's create our engine, and let me, so engine is simply that we are using Postgres database or Postgres instance. That is our database engine. That is also done. Now, and another thing is this engine is basically a wrapper around our Postgres engine or a Postgres instance so that we could talk to database. And now next thing we need to create is called as metadata. And these are all LlamaIndex stuff. As you can see, if you we are creating this metadata object, and if you look above, this is where we have imported this. Now this metadata object is simply a collection of table objects and their associated schema constructs, and we will be pulling it out of our testdb database. Now once that's done, let's also load our SQL database from this engine or this metadata. So what is happening here is primarily that one more thing I need to do. So what is happening here is we are creating abstraction upon abstraction. First we connect it to database instance, and then from there we connect it to metadata, and from metadata we connect it to database. Okay, that is cool. Then now having said that, now we have our SQL database initialized, and let me run it again. I think I missed the S here, my apologies. So just ignore this command for now. Okay, now our engine is initialized, our metadata is initialized, and our SQL database is initialized. Now let's import our natural language engine, because we need to talk to database with natural language, and we have imported this library. And now specify which table we want to talk to with this query engine. As I showed you earlier, that we have two tables. One is called as companies and contacts, and that is what we are passing it, that we need to talk to these tables, and we are using our SQL database which we have just initialized here. So let me run it. So this is our query engine which has initialized. Sometimes it takes a bit of a time, so don't worry about it. And now let's give it a prompt or question in natural language. Now when you ask from relational databases like Postgres any query, you normally put it in select static from table name, and then this is a query for SQL format. But here if you see, I'm asking it who works in AWS. If you would be doing it in SQL, you will be asking it select static or select name from contacts where company ID is equal to something like that. You would be doing joining company ID with company ID in parent and child tables. But here I'm simply asking it in natural language who works in AWS. And now let's send it to our query engine, this prompt, and let's wait. Now print this response. There you go. So how magical is this? It says John Doe and Jane Doe works in AWS. Now if you go to Jane Doe and John Doe in our PG admin, you will see that AWS's company ID is 1. If I go to contacts, look at company ID of John Doe and Jane Doe, it is 1. It has correctly pulled out the correct one, which is these above two. Now let's give it one more example, and as I like to push the limit, so let me try to break it. So I'm just okay, I just need to put it again here. So what I'm going to ask it, I'm just asking it, let me clear my screen, sorry, let me to make it a bit clearer. Come on, there you go. So now I'm asking it how many people work in GCP. Let me send it to LLM. Let's wait for it to come back. Print the response. There is one person who works in GCP, and if you go there, if you go to PG vector, you can see that GCP's ID is 3 and GCP3 is just Smith. This is amazing. Now let me also just make it, I'll ask it how many people work in GCP, what are their names. So let me give it again. Let me go back to my putty window, and then I'm going to ask it how many people work in GCP. That's it. Let me send it to response. Let's wait for it to come back and print the response. There his name is Smith. How magical is that? And I have been working in databases for the last almost 20 years now, maybe more. And I can tell you that whenever I need to write these sort of queries, sub queries, it's always pain in the back. You always miss something, and even if you manage to get a complex query to get this sort of data, the query is suboptimal. You have to do a lot of tweaking to make it optimized query. But look at this. I mean, here I'm not using any structured query language. I'm just giving it a natural language response, and it is just doing the magic like anything. So simply amazing. And you can see that maybe no one needs to learn a structured query language SQL anymore, because when we have these LLMs, who needs SQL or PL SQL for that matter? So amazing, guys. I think I hope that you appreciate my excitement here, because this is simply out of this world. Let me know your thoughts. If you are stuck anywhere, any comments, very happy to help out. And if you like the content, please consider subscribing to the channel. And if you're already subscribed, do me a favor and share it among your network, so that subscribers will increase, and that always helps. Thank you very much.